Good afternoon. Welcome to the session of real-time operating systems. In our previous discussions, we discussed about the general real-time algorithms, and also we spoke about lastly about a kernel. That's how a pseudo kernel is formulated and how do we work with real-time kernels. We also spoke about what would be the different aspects and using interrupts and preemptive type versions, coroutines, mailboxes and buffers, other stuff. Now, in this session, we are going to look at one more different aspect, which is about the real-time languages. Actually, if we see that there are 4 building blocks in anything. One is the operating system, which is the real-time operating system. Our entire course enforces that. The second aspect is about real-time language. About a language is required, because ultimately whatever the user does, he requires a coding language or something to formulate an algorithm or implement something. So, that is required to communicate to the operating system. Then the third aspect will be a real-time database, and next we will require communication, which should be real-time. So, a database is required to store the data, whatever we are going to do, that should has to be also real-time in nature, because we will be formulating real-time constraints for all these things, the different aspects, and also the communication. So, if you look at how that differs, first, we have some issues to be highlighted. One is why really a language matters. The language is something just like how we require a language to communicate between people. A language is required to communicate with the operating system. In our case, the real-time operating system. So, we need to study that. So, that is the prime reason about why we require a language. So, without a language, we will not be able to communicate with the operating system any algorithm or any particular way we want the operating system to what task we want, we will not be in a position to make the operating system understand. So, the language is something which is a communication media. Then we have something about the language taxonomies. The different classifications and different types of languages are also required. The third aspect is the Cardell's matrix. Cardell's matrix is something which is required for a language. The Cardell metric is one which enforces about different types of aspects, and also it also tells about the Cardell matrix is about the ease of operation, like what should be the basic type of the user's effort, what should be a team effort, what should be the compiler's effort, and what should be the execution effort. So, these 4 points are covered in the Cardell's matrix. I will discuss about that also in detail. Then last is the schedulability analysis. Now, so far from our discussion, it is evident that we have a schedulability analysis to analyze different aspects, and also we know that the schedulability aspects, the analysis is like basically if you see that what is the resource utilization and how far we have seen the task get scheduled, how far we are achieving that. So, a programming language represents the nexus of design and structure. So, the nexus of what type of language, what type of design we want, what type of structure we want, and basically how the source deterioration takes place and how we have to see the deadline misses. Now, generally when a task arrives, either it misses its deadline or the resource is inadequate to complete. So, basically the programming language has to cater to this requirement. The software build depends on tools like compilation, generate binary, link and create different binary objects. So, what happens is, when we have a particular, the software should be inherently capable of translating the language to the operating system. It should be in a position to compile, it should be in a position to form the executable, and it should be in a position to do the execution on the executable. So, ultimately coding is, it's given a very relatively little time. So, actually it's actually only a means by which we communicate what we have in our mind on the algorithm. So, why it matters, if you ask, is it is a craft like way to see the type of qualities and skills which has to be done. It can be built with a wide range of languages. So, the taxonomies is, it basically depends on the executables and what type we are doing. And generally if you see the language part, it can be either imperative, it can be functional, it can be logic or procedural or declarative. Why we say it can be imperative means, if it can have other features, like it can have object oriented features. Now, if you look at generally in embedded, what language we would be broadly using is all ADA related stuff. Why we are using ADA is basically it has the UML support. Now, if you see all our cheddar tools and other things, they are coded in ADA. It's a combination of ADA 95 and we work on that. That can be also functional. Functional is basically like if we are writing a C program, we basically work on the function type. or it can be with logic. Logic is something like Fortran, where we work with formulas. Procedural or declarative. Procedural means C is a procedural language. Declarative, it can be having declarations like basic or something. So basically, if you see that the language classification, C, C++, and Java, all these things are high level language. C++ is an object oriented paradigm, and Java is a small subset of it. So ultimately, when we work on the language, it should be there. We have some functional languages. Functional languages is something similar to like Lisp. Lisp stands for list processing. It's basically working on linked lists and other functions. Then we have logic programming, something a similar case where we give a formal statement and construct the premises like based on the dependencies. Usually Prolog is one such language which has these features. Procedural languages, of course, as I told you, C is a procedural language. Basically it uses functions and it has mainly procedures in it. Declarative condition, it's used for the rules of to define the solution to a problem. It can be spreadsheets, it can be Excel, etc. So the object oriented has a style of programming. So if we talk about the Cardali metrics, generally we have 5 Cardali. One is the economy of execution, how fast the program should run and how far the execution speed should be there. As I told you, the 4 aspects, the Cardali metrics is one which decides the scope of the language. Now if we see in a language, in any language, now you say C itself, we have some scope resolution, we have something called as the storage classes. The storage classes of C are basically auto, static, register and external. So these depend on the scope of the variables and how far the language can be used. The same language is to be extended. For example, if I am going to bring it into embedded C, that same storage classes will not hold good. So Cardali metrics is something which decides on these factors. One is how far we do the execution economy, like how far the executable has to run and execute, how far the compilation should take place. Both these aspects go hand in glove. When we are compiling, proportionately execution should go. Then we have a small scale development, that is an individual effort, how far the programmer should contribute and how far the large scale development as a team of programmers should work. And the basic features, how far the language is expected to learn or use, it should be flexible. If it's a very complicated language like COBOL and all for business, it's little very complex. But see, generally some languages should be user friendly and at the same time it should meet the requirements. So one aspect in the schedulability would be, we need to know what would be the compile time. Now generally if we see about the execution time, the performance is in schedule can be achieved either by removing some language constructs. Now one way is we talk about schedulability. As I already told you, either tasks should accomplish deadlines or they miss deadlines. In other cases there is inadequate resource. So if a task, the schedulability rate comes down, it's due to 2 factors. Either the task is not generally scheduled or the task has inadequate resource and it's unable to be scheduled. So there are 3 ways. One is it to remove the language constructs that destroy determinism, such as the recursion and while loops. So there should be a type safe language mechanism for this. So the programming language is in conjunction. One thing is, if you see that how far the explicit control is taken place, it can be having a real time language, should strive to achieve this control. So as I told you, the criteria Cardali works out is Cardali formulated to 5 points by which he is going to evaluate a language. These are the performance aspects, rather we can say. One is the execution pace, the compilation pace. Both these go hand in glove with the operating system. These 2 points. The third point will be the individual effect, small scale and large scale as a team. These 2 go hand in glove between the individual user's effort. And the last point is what is expected exactly from the language. It should be flexible. The language is an interface. It's a bridge between the user and his team and the execution compiler part. So if you look at it, generally in an assembly, the assembly language, the preliminary language is machine language. Machine language is nothing but a combination of bits, and as we all know that bit is a binary, it's the smallest information which is transferred in electrical. A combination of that will be called as a byte. So for 8 bits. So what generally is a machine language basically works in bits. The next level of language would be an assembly language. As we all know, assembly language uses mnemonics. Actually an assembler is one which translates. The mnemonics is something called as opcodes, where generally what it does is it has it does not, the main disadvantages of this is it does not have the features of high level language. It's very hard for a programmer to do. So the last point of Cardali metric would be discarded. It's not flexible. It is unstructured. Like the abstraction is limited. Like if you see in a C language, we get more formal descriptions and things, and it is tedious and error prone. Secondly, it's non-portable. Like if I am using it on one device, I cannot change the same thing to another assembler because the code set will be different. So basically, it is rare that even the programmers can have a good optimizing compiler. So it does not have certain macro instructions or when timing constructions are tight. So the complexity of this language is higher. Like what happens is, if we are used in some cases where we are having an equivalent instruction and some other language instruction sets may not have that similar instruction. Like for example, in some things we have jump on carry, jump on no carry, whereas in some other processor this thing may not be supported. So the complexity is there and the instruction set also is different. Of course, this is decided at the manufacturer's level. So one more part is, we require an assembly file to have a pragma code. So it requires an assembly code to be placed in line with the high order language code. So if you talk about a procedural language has the following features. One is a parameter passing technique. This of course it should be obvious because we do this in even C. In C language we work with pointers, but in general what we will be calling this here as call by value and call by reference. Okay, that we will discuss in detail. Then we have something called as global variables. Global variables of course is common, which we have discussed also. Then we have something as recursion, then dynamic memory allocation, typing and exception handling. So these are the features of a procedural language. Then modularity, Cardinalist metrics and the language support. So if we talk about the overview, generally what we will be saying is, the program should be organized as a sequence of steps. When you write a program, it should be easy to debug. If there is a bug in the program or bug in the source, it should be the programmer. A good programmer is one who writes a language, writes a program with minimum set of code, minimum lines of code and minimum optimization. That the code should not be very lengthy, and also it should accomplish it should be effective. Like what is the task, the logic should be as simple as possible. So that is a good programming feature. So if you write this languages, it should be capable to allow these instructions. The language itself should be supportive enough for the programmer to have these features. So an effective programmer might have a skill of doing things well, but the language we need not support. For example, if you talk about assembly language, if we are going to do some sort of functionality grouping and other things, assembly language does not have these features. Basically it's non-portable and this thing, whereas if I am having a C program, C is obvious, it can be used on any other device also. Generally we have cross compilers, we have all these things which we have come across in embedded. So that would give portability and easy flavor. Then next point would be is, the subprogram should have desirable properties of the software. So it can be modularity. Modularity is one is, it should be as modules, so debugging is easier. If you are writing say 1000 lines of source and we are unable to do that, it's going to cause a problem if there is a bug also. Then reliability. Reliability, if we say the code should be reliable, like supposing if I am giving this code on something, it should not have any other work in the other way around. Then reuse. Reuse is something is, if I am using this code, if I can call this as a routine, as a function or a subroutine for repeated use, this is something in recursion, it will be helpful. So some languages like ADA 95, C++ has these features, but others do not have. So the next point which we will be discussing is the parameter passing techniques. As I already told, parameter passing is one of the important features. Now this feature basically is not available in some languages like Fortran or BASIC and COBOL, because but if we see this in C++, we have this thing of the pointer concept. Normally we refer to as pointer, it's called, but here what we refer to this is call by value or call by reference. So either if we are doing call by value, directly we can give the value. Now if you talk about in an microprocessor, we have different addressing modes. One is called as direct mode, the immediate mode. Immediate is directly giving a call by value. Then we have direct mode. Then register direct, something like this is call by reference, where it points out to a register. Call by direct mode is something like call by value, directly you load the value to register. So these features are available, but these are some of the features which not all language possess. Similarly, it should have a formal parameter or an actual parameter, then there should be a test to be performed on the output. So if we talk about call by value, call by reference, we generally call out for an address. The address contains the parameter. So in this case, what we have to do is we should ensure that the address which we are pointing out contains the exact value. So having 2 or 3 loopholes would create a problem, but directly this flexibility in the program allows us to modify the value. Supposing in the code, if I want to make a change in the value, I need not directly go and change each time. I can change in that register, in that address, the value directly. It gives the user the comfort of maintaining a fixed code. So generally it's called as, if call by reference, it will take longer, because this is the disadvantage of this process, but its advantages from the coding point of view. Similarly, call by value is quicker, but it does not give flexibility. Now generally in the reference indirect mode, instructions and calculations need to be performed. So large data structures have buffers in this way. The next point which we will be discussing is about global variables. Now if we talk about global variables are generally, what is a global variable? It must be obvious to you from C language. If we talk about a local variable, the local variable generally it is actually fully available in that register. It's only visible to that particular function or module. If we talk about in C++, if we have a class and object relationship, a local variable would be only predominant to that class, whereas if a global variable would be in the entire program. So if it is a global variable, it has more advantages. Like I need not each time call that value. I need not have an access specifier, and it's easily accessible also. In some other part of the program, I can easily call it. So this is one of the features, but generally this way of restricting the access is not predominant in other languages. C and C++ has these features. But global variables can become devastating also. Supposing if there is an unauthorized code and it's introduced there and it accesses the value, it can create a problem. Some sort of variable which should not be. It's something called as dead code elimination. If you have a dead piece of code which should not take action, the global variable data is accessible to that piece of code also. It can cause devastating effects. So normally the reference when we are giving it, so that is the reason why we have something called as access specifiers to restrict the access of variables. So if we talk about languages like Fortran or other things, we have some common declarations. For this, we require global variables either to be avoided. We can have timing warrants, or if you want, we have parameters to have this code. The next feature is recursion. This is one of a very an important and interesting feature also. You call a function calling itself. So recursively that function can be, if a simple thing is using a factorial program. You need not, where we know that the factorial is a product of the numbers predecessors before 1 or up to 1. So we can simply write a factorial program recursively. So this is one of the features. This is used when we require, this will also avoid the usage of large quantum of code. Supposing if you have a function and you repeatedly call itself, you don't have to have very large quantum of code, and it is also, but provided the language has this feature. So this is elegant and often does not have, but it has some negative performance impact. Like indefinitely if you call, it will create a problem. Depending on the number of calls for the function, we need to use it. So otherwise, if there is a runtime stack, it is possible to determine the size of the runtime memory requirements. Iterative techniques such as while and for loops must be used here. Then secondly, it guarantees recursive code. Then the next point would be dynamic memory allocation. Dynamic memory allocation is something that if we don't know the exact size, now normally we know for an array we have a fixed set of numbers. Now suppose in our link that array is a static it's a static memory object, but supposing we don't know the exact upper bound of the data can be indefinite and we don't know. So that's where we go in for linked list. Linked list is a dynamic memory structure. So what we generally do, this data structure is needed in real-time systems, because normally in real-time systems it should be in a position to handle data which is coming continuously. It could be on the fly. It need not be like the data structures cannot be in a fixed value. Like supposing any data, supposing if the data this data structure is supporting only up to 5 data types, and if you are having 7 or 8 data values, again this is going to kick up a problem. So similarly, we need to have a data structure that is dynamic in nature and takes in data on the fly. So this is one of the aspects of a thing. So, but this can also be devastating if we are not, when the memory, it can tie up huge quantums of memory chunks and create a problem in the memory allocation. So something like this avoids the usage of a buffer. normally in one way. If you don't require for the data, if you know if it's dynamic and the data is coming on the fly, we don't have to, provided there is a synchronization object and it is able to quickly catch the data structure, then in that case a buffer will not be required in synchronization. So directly the linked list is one. We have a head and we have a tail, and each one the nodes are being added. So we use a point, it can be linked list, trees, heaps, all these things are dynamic data structures. It is the economy, clarity and economy and dynamic allocation. So in cases where just we require a pointer to pass a structure, it can be dynamic allocations. It's reasonable also to ensure that the compiler will pass pointers to large data. Languages generally need not allow the dynamic allocation, but it should have data structures of fixed size. So C, Pascal, Ada and Modular 2 have dynamic allocation. So it is flexibility is sacrificed and memory requirements must be predetermined. The next part is typing. Type languages require each variable and constant to be of specific type declared before use. So what happens is when we are using a type, like generally C has a few data types. One is integer, float and character. There is also something like double, long float, etc. So depending on that, the corruption can be avoided due to unwanted type conversion. So if you give the right type, we need not make a type conversion from character to float or other things, unless it is absolutely essential. So the programmer should be precise in his code. Another type of thing is compiler type checking. It is a way to find the errors of compile type and rather than using it at runtime. So abstract data types may contribute to the execution time penalty, and it's often needed to support the abstraction. So some languages are typed, but they do not prohibit the mixing of types in arithmetic operations. So the performance impacts and hidden promotions is also there. Like supposing if we use unwanted type conversions, which is not absolutely essential, again the code size and code elegance will be affected, and also it's not a good programming style also. A programmer should be having all these features. It's something like his tool set to do a good job. So basically the performance impacts and hidden loss of accuracy, all these things should be avoided. Another feature is exception handling. This is the most important feature, I would say, for a real-time system. This is the feature which actually differentiates a conventional system to a real-time system. In a conventional system or a conventional operating system, this feature is not mandatory or not essential to be present, but in a real-time system, particularly a real-time operating system, this feature should be predominantly present. The reason being is, from the definition of a real-time system, we know that it should be susceptible to failures and it should be capable of handling exceptions. So that is actually a real-time system. When we are going in for our basic embedded applications that are hard real-time, they require the system to function continuously. Like if it's an aircraft application or an automated car or something, in that case it cannot even tolerate a failure for even a single moment. It would crash the system. So normally we will encounter in any programming a number of exceptions. Some common things are negative of square root of a negative number, divide by 0, and some user defined condition pointing to a value where call by reference to a register where there is no value. All these are exceptions. So the road should not end. Actually, if there is an exception, it must come out of that thing. There should be a fallback strategy. So this is something called as an exception handling routine. So generally, poor handling of these exceptions can result in failure and degrade performance. A real-time system generally should have all these exception handling features. So one thing is, now in C and Java, other things we find this store, try, catch mechanism. C provides a signal of raise and signal. So some exception handling features are available. The next point is the modularity. When we talk about modularity, is nothing but code should be formulated in modules and it should support the principle of information hiding. So for a real-time system, a real-time database, it should not be, that we will be seeing later, the data should not be obvious to some other level before the committing or something. So that information hiding and modularity is something. Now the ADA package has some specification and declarations to be there. So it is compliable entities with enhances the application in black boxes. So in Fortran there is notion of having a subroutine and separate compilation of source files. So the C language provides for separately compiled modules and other features. the price to pay is the modularity will have some overhead, but it gives some elegance in the code. Like when we are going in for parameter passing and other features, the good modular design, this will be the condition. Economy of execution should be high, and therefore compiler is efficient. So for the Fortran focused on code optimization, and also the large systems is efficient. Modules can be compiled independently. Now supposing if the module is not elegant enough, like it cannot do a good job, like we are finding a lot of bugs in that. In that case, this feature will go for a task. So when the idea of having it as a separate module is debugging should be easier, and so when we are taking a large system and trying to do that, the code optimization is one feature. Secondly, there should be the small scale development should be economical. So the type checking should be in a position to catch the errors. Another option is data abstraction. So data abstraction, when we say, we must be in a position to have large scale code development based on the interfaces. So it should be economical and it should have a learning curve. So if we talk about object oriented languages, the synchronizing objects, one is synchronizing objects is essential as far as if we don't have, if the producing and consumption rates are not matching. Now supposing if the code is communicating something, the data structure is trying to send, there are two data structures and they want to communicate data, we will require a buffer or we will have to synchronize both in the absence of it. So another feature would be garbage collection. So the garbage collection feature is something where we throw, otherwise what this is going to eat up a hell of a lot of space. So more data space and other things is being utilized. The garbage collection feature is absent. It is not going to make an effective language. So Cardinal's matrix and object oriented language, yes. So the Cardinal's matrix is one which evaluates a language from the key focus on what features the language should possess. So it can either be object oriented and procedure oriented. Now C++ is object oriented, whereas C is procedure. Object oriented has higher level of abstraction and encapsulation. So when we have the high degree of data abstraction is one, it's mainly the access specifiers in the class object relationship to be public, private and protected. We need not make it entire global. So if I told you if there is a dead source code or dead piece of code in the program, it should not create a problem to access some data which is critical and tamper it. The code can be doing something by changing the value which is unintended and unknown to the programmer and not intended by the task. So in that case what happens, there will be a problem with the data. So that is an issue. Second point is inheritance. Inheritance, yes. If one class has to inherit the functions and features of another class, it can inherit it. As we know that there are in C, we have different inheritance, single point inheritance, inheriting from multiple classes or multi-level. Then polymorphism, yes, polymorphism is a feature like in C++, all these things. It's something like it is runtime polymorphism and compile time. So it can be its early binding and late binding. So actually polymorphism, as the word indicates, it is of several forms. So many forms, poly means many and morphism different. So the code can take different forms and other things. Then messaging, yes, the data between that it can be. So the object benefits of the object oriented is the increased efficiency of the program, reliability and extension along with reuse. Reuse is something like the recursion, the case of extension potential and also the reliability feature. So generally if we talk about it, it should support more effectiveness in that way. So when we talk about a language should be in a position to take up the entire thing. It should have all these features. Now we spoke about several. In the absence of any one of these features, in fact the programmer may not be in a position to explicitly accomplish the requirement. Now some tasks might require this. Now a simple example would be a real-time task. If we take a real-time task requires a exception handler. If the exception handling feature is not available there, we cannot use that language for that. So that is the point where we require real-time languages. So if we are going to use a conventional language, the scope resolution and some feature is not available, it's not going to help out for the programmer to achieve what he wants. So the choice of the language is also primarily important. So synchronizing objects, if we talk about objects, yes, there is a lock. Now supposing if we have in any object, say if you talk about class, for each object there is a mutex is associated with an object. Mutex is nothing but a lock. Whenever the object enters a critical section, it has to encapsulate itself. So either the locking can be internal or external. If there is an internal thing, each public method will acquire that lock, and upon entry and releases the lock on exit. It should not have the lock without, if it does not release, the resource would be unavailable to others and it will result in starvation. So, the starvation problem is we have to have every object should have a fair chance to access the critical section. The next point is the external locking, where the client is responsible to acquire the lock and it would also be his responsibility to release the lock. So, when we are having an internal locking, we have to have a foolproof mechanism to ensure that the object itself is able to lock and unlock itself accordingly. So, if it is not in that condition, it will result in problem. Another condition is the external locking. External locking is to acquire the lock and before accessing it should subsequently release it. The next point would be synchronization. As I told you, why we need to synchronize. If we don't synchronize in a real time condition, if there is a data loss between two objects, two data structures, there should not be data loss, number one. This was in our previous discussion also we seen in the kernels. If supposing if there is a difference in production and consumption, what will happen is if we don't have a buffer, then the data is going to lose. So, if there is more data loss, we will not be able to maintain the consistency. So, there are different objects. One is encapsulated objects. Some synchronization is needed, and the lock of the enclosing object should also be protecting that object. So, the next point would be thread local objects. So, the object should be accessed by a single thread, requires no synchronization. Objects that are to be accessed by a single thread requires no synchronization. So, the thread should be local. The third point would be migration, like objects would migrate between things. So, these things there is no synchronization, because if when the migration overhead incurs, but the object is being fully transferred. So, the ownership requires requires synchronization. The next point is immutable object. An immutable object is it is never modified and after it is instantiated. So, it requires no synchronization when accessed by multiple threads, since they are read only. So, there is no question of modifying the value. So, when it is a read only access, this is nothing, there is no transaction actually going on. So, the synchronization part is not readed, because either if there is a reads are done in different phases, it is not going to change the value, but if there is a write operation, consistency has to be maintained. So, this of course, we would have discussed also in our architecture part, like read after write, write after write and write after read, var and raw hazards. So, if there is a data hazard, that read after the write, that order should be maintained. Write after write, similarly the order should be maintained. Write after read also the order should be, the first write has to take place followed by the read for data consistency. But read after read is not a hazard, because the value remains same. So, this is an immutable object where the object does not change its state and it is never modified. Unsynchronized object, yes, that is an object which is belonging to a single thread program and there is no synchronization, because within that thread all operations take place. With the other things, if there is a multiple thread, even similarly thread local objects, we only talk about a single thread. So, synchronization between migration, synchronization is required. Encapsulation, so only we see in migration of synchronization. The rest of that is not required. Similarly, immutable objects also. So, the next feature is garbage collection. As I told you, if we are not having a garbage collection feature with the language, memory could be eaten up to a random pace. Like any allocated memory, it is no longer being used and it cannot be this thing. So, it is generally associated with the object language like C++ and Java. So, it can be detrimental to a real time performance. So, it can be unpredictable in performance and are detrimental in real time. Garbage can be created in procedural language. For example, in Pascal or C, garbage is created by improving deallocation of memory. So, it can be created in a procedural type or it can be created in an improper way. If they are not using the particular code, it is throwing some values which is not detrimental and that thing. So, generally the code should be designed in such a way that no garbage is being, no values are being. So, that is what we have something called as testing. In that code testing part, whether it is effective or not, is there any problem where the garbage unwanted values are there, that can be minimized. If this feature of the language is not available, garbage collection mechanism is not there, the language inherently should not, the code itself should take care that no values, unwanted values are being thrown out. If more values are being thrown out, that is going to have a detrimental effect on the memory. So, Java supports the garbage collection, whereas C++ does not have. So, when we are designing a C++ code, we must have this feature in mind. So, it should be implemented in that way. So Cardinal's matrix, yes, that takes care to a certain extent that there is no loss of values and thing, but ultimately it is also partly vested in the programmer's interest that he should achieve what is required. So the efficient in execution, so every routine has a method to additional indirections through having tables and optimizations such as inlining. The compilation efficiency economy should be low. There is no distinctive between the code and interface. Like supposing if a compiler is doing that, if the compiler should be also in a position to take the thing like between superclasses and subclasses, and it should be in a position to give an output. So another part is small scale development. As I told you, the individual's effort. The individual, if he is capable of doing things, the entire team's effort need not be. The large scale may not be. But if supposing the individual is giving a poor performance, again large scale the team has to contribute more. But ideally, the Cardinal metric should take care at an individual level also for a language and also the large scale overall development. So much of the back work should not be available in re-implementing a class condition. So it should be economical and uniform, and everything it should have a different manager of class varieties. So when we talk about it, there is still no agreement whether it is better for real time. So if we tell an object oriented, it can be unpredictable and inefficient. Also just as easy to build an unpredictable system, like if C and C++ does not have a feature, but the programmer's efficiency has to be there to make it predictable and easily built. If it's not done, there's a problem. The same cases on arguing about garbage collection. Now garbage collection, if we are not going to effectively handle at the programmer's level and the language does not have, that can be a devastating effect on the memory side. So the other inefficiencies is based on the time penalty and the late binding also when it's at runtime. So object oriented, yes, versus procedural. If there is an attempt like to use inheritance, now as I told you, if we have an attempt to use inheritance, class inheritance is some feature where we will be reusing the code. Now if for every subclass there should be a subtype, but it should be having an anomaly, like the reuse should be most of it inheritance, there are some anomaly rejections. Now supposing if we talk about procedural languages, now C does not have some features where we can inherit from the subclass, but whereas C++ possesses that. So this same arguing in the similar way, if we see in about Cardinal's matrix, it can also show the different class libraries also, like how whether it is superior with terms of the individual effort and the team effort. So of course if we talk about a team effort, yes, if supposing when we do a testing also we do it as a team, but when it is at the individual level, the individual contribution is also equally important. So we will not be in a position to see whether how far the schedulability, substitutability of an individual to the entire thing is available. So but inheritance, yes, inheritance for the reuse, like supposing if we are going to take a particular class module and we are going to implement, we are copying some features, it can be used, but not all features. Again, each class should have its own mark and its own blend. So similarly, if we talk about it, it can be easily built from C++, but some features need to be there, addition to, like these are the standard components which a language should possess. This is from the experience actually, but some features also, like the task being assigned also might have some inherent values. We talk about the task has more requirements and the language has to have more features. Then in that case, so we need to strike a balance rather than saying that this all is up to a certain point, like saying Cardinal's matrix, yes, it evaluates a language and how good a language should be, but it is also partly on the programmer side. So that's what is also Cardinal matrix saying. If the programmer's effort is going to be very poor, then in that case even how good a language is being there, it's not going to be there. At the same time, if the task requires some feature, the programmer should be in a position, if that is not available with the language, he must be in a position to develop it. This Cardinal's matrix is to evaluate only a general language which would be helping such applications. But in addition to that, there are some other factors which have to be taken into mind. So the unpredictable argument is whether we really need it actually with respect to C++, which does not use this thing. If supposing if they are not able to predict, generally garbage collection has to be there. Supposing the program is not in a position to identify if there will be a loss of data, whether there will be a loss of more values will be coming out, or anything. In that case, it is better to have that feature, because at a later point of time when the memory is lost and the data is lost, we will not be able to recollect. Now if we are giving a package, this paths should be evident in testing, but when testing also does not throw results, it's better to go in for a feature language with that feature to help out in to prevent unwanted problems of loss of data and other things. So something what we commonly call is, in a built-in language we have something called concurrency. Concurrency means, like parallelly, as I told you, whenever we try to, there are two objects, like if supposing in morning we discuss something around about the different types, like when there is a sender and receiver, consistency. So again we have to see how far there will be data will be transferred across. So something which between the class we have something called as concurrent APIs. APIs like which are, they are having wrapper classes, like having a small set of functions within a particular class which can be wrapped. So generally in this there is something called as POSIX, Portable Operating Systems Interchange Standard. So what happens is, it should make these wrapper classes are some features which make it more portable. Like all features of the language need not be available for one particular flavor. Like you can have multiple applications which have the same set of classes, and also it can have different. So if these concurrency APIs are available within that language, it can be used. So generally it's a mixture, rather like how we would call in a benchmarking. How do we make benchmarking between a system? We use a set of programs which are evaluated across. So this wrapper classes and concurrent APIs would be a mixture, and that mix would also generally use it for this concurrency patterns. So the concurrency may be poorly supported at the language level, and it's not an issue since the developers use libraries instead. So the languages should be used in real time. Each situation needs to be separately considered. So the survey of languages, if we talk about different languages, we have something like ADA 95, C, C++, C#, and Fortran, Java, real-time Java, OCaml2, and some special languages. So as I first in the beginning of my discussion itself I told, like all C tools are, we work on ADA. ADA basically, even if we talk about our Cheddar scheduler, it works on ADA. ADA is generally, why is because it has a UML support. Now in Cheddar we have something called as STUD. STUD is actually the UML support tool, which generally it's provided by Elitist team, which takes care of the module wise. Why we require a UML support is, supposing if we are doing any particular scheduling, normally the schedule side should be in a position to synchronize with the real time condition. Now whatever scheduler we are doing, like supposing we are seeing some constraints on task utilization on something, we also, this aspect is different as far as you consider the hardware part. Now when I am porting this code onto using a cross compiler and I am putting it onto a processor chip, the processor chip is going to evaluate this. So the processor chip will have something. Now each processor will have its own instruction set, the clock frequency will be different, and the instruction set computing and all these things will be varying. So this is something where we do profiling. When we profile a particular code or application, we get these parameters, then we go to Cheddar for the scheduler, and then down the line it goes into the processor. So when it is going into the processor, the hardware will differ, like processor will have a different set of task parameters. I am not saying like if an execution time on the scheduler is showing me at 5 units, when I am running based it on a processor prototype, the processor parameters will be different. So it can take more than 7 units. So that depends. So that's what I am saying. Exactly we map it on. For this mapping only to get it, we need actually a UML support to exactly visualize some particular prototype scheduler and check it. Then the next part is C. C, as I told, it is invented in 1971 by Dennis Ritchie in AT&T Bell Laboratories. Basically, if you see the storage classes which we use in C are auto, static, external, and register. So C has a feature, it's a procedural language. Why it is being effective is it supports the concept of using more functions. It has several features. It is modular based, like rather some languages which do not have this feature. So debugging is easy. Secondly, it has something like the pointer concept, call by value and call by reference. So the variables declared can be volatile, like they need not be having the value permanently. either we permanently store the value, so that is not a non-volatile type. So but generally when we are using in handling memory mapped IO, if supposing the values are permanently embedded, it can create a problem. So it should be typecasting, like between data can be misleading to mysterious problems. So if there is an exceptional handling between signals, it can have a set jump and long jump for this. So overall C is good, but for embedded programming it requires structure and flexibility without complex language restrictions. C++ is a hybrid object oriented language that was originally implemented as a macro extension of C. So if we talk about a macro extension, generally the hybrid language can have different features. So it should have all characteristics of an object oriented language, and it should work with classes and class methods. So the functions should be connected to classes. Like generally between classes there could be a connectivity, but that's one aspect where we can bring in the concept of global variables. But apart from that, if there is no connectivity also, we can introduce, but not having connectivity would be ideal, because supposing, as I told you, the problem of having dead code. Dead code means some code which we have been unintentionally initially introduced and we have removed at some point. If that code is going to be there, and if there is overall connectivity and global variable concepts, that data could be tampered. Now supposing if there is some function which changes the value of the data, supposing I am using this code in an aircraft application, an automated or anything, the value is changed concurrently, it's going to create a problem with the main source. So the low level control inline method should be having a runtime call. So that is one. So unwanted complexity, another thing is preprocessor directives. They also weaken the type checking. Preprocessor is using macros or something which we are trying to embed values. So the values, it does not give more flexibility in doing type checking and validation. The value is wrongly been embedded, it's a float value, we cannot change the data type. So again that is going to create a problem. Similarly, if supposing the value is float, so that data type of that variable or thing cannot be modified. So it is actually embedded. So misuse of the pointers, like supposing pointers, if they are not used in the right thing, it can create a problem. The pointer also has a data value memories thing which is occupied. So the next part will be having dynamic data structures. Now dynamic data structures, yes, linked lists help out to a large reason, but if linked lists are not, if they are using it at a wrong pace, like if supposing it's the data, you're going, if you at the end of the show you have to free up the memory, unused memory blocks. If the programmer does not do that, that is going to tie up large volumes of memory, and rather more fragmentation will not be available and will be creating more problems. So C# is a C++ language that uses a operating environment, has similarities to Java. So C#, Java, as we already know, it's a small subset of C++ and C. Not all C++ features are available with Java, and we have a virtual machine. C# is also a smaller subset. A recent version uses a combination with .NET. So .NET has most of Windows and other things. It is used for hard real-time systems, but again other features may not be available, like garbage collection and other schedulability aspects may not be available. So C# and .NET could be used for some soft real-time firm applications. I won't say it is recommended for hard real-time systems. So hard real-time systems could create more of a problem. Fortran, yes, Fortran is the oldest language. Basically it is still used in modern real-time systems, but it is basically used for formula and logic. So the reentrant type of code, like repeatedly using the code at different points of time, was not supported initially by Fortran. So efficient only when there is still essential to optimize the performance. So it could be weakly typed, and it can be used to design highly structured code. That is, there is no exception handling, like as I told you. But again, this cannot be used for a hard real-time system. So as our definition goes, for a real-time system we need exception handling feature. The language itself is not going to support, and it is not possible, theoretically speaking, for a programmer or a designer, a real-time engineer or designer or embedded programmer, to have all these features in mind. Now exceptions can come in any form. He cannot code in all. Now if Java has an exception to try throw cache or something, now supposing if there all exceptions cannot be visualized, and further the language itself does not support it. So this cannot be used for hard real-time systems, but maybe for a soft real-time system. Even for a soft, generally it's not suitable for a real-time system, but maybe if soft real-time system where it's not very stringent, it can be used. But in many legacy systems and applications, we use Fortran, particularly Visual Fortran, which is a combination of .NET, also Visual Studio, and this. It was also used with the combination of .NET. So embedded systems written in Fortran have, actually we use the other assembly part also to take care. But as I told you, the code flexibility is not up to the mark. Now Cardell's metrics spoke that it's also part of the individual effort and the team effort of the small scale and large scale integration. So this aspect is not taken care by Fortran, but Fortran gives a feature to handle it with a combination of other languages and other things like assembly language. So the next part would be Java. Java, as I told you, it is an object oriented language. It's more or less like C++, but I won't say it is actually C++ because Java has certain features which is not away. C++ has more features and Java has a smaller subset of features. Like all options, I would rather put it in this way, like all programs in Java can be executed in C++, but not the vice versa is not true, because some features may not be supported by Java. So it is rather, it compiles it into machine independent code where the execution is managed separately, which takes up the object code as a series of directives. So it is actually basically write once and run anywhere. So the basic type of Java compilers is, it is used as a bare metal. So bare metal code is, if you see that in the normal condition, the code directly uses it onto the Java compiler. So like C, Java supports a call by value and reference to an object code. One of the best known problems is it's a garbage collection utility. If garbage collection utility is not available in C++, even Java cannot be suitable there, but this gives the programmer, it's actually a programmer's friend, because actually the programmer does not have to take care of understanding that the GC utility is available. He is going to write code with not having that not being very thought conscious that the value should not come out more, and it gives more user friendliness. So that's why most of the Java applications like C and C++ and Java, they prefer, because of this feature, GC feature, and also some other basic features of exception handling and other things. Then the next thing is real-time Java. Real-time Java is one step ahead. It has more GC utility features, and it would also have something like it is suitable for embedded applications. Like if we see the core requirements, yes, it can be used for real-time specification of Java. It also has some sort of bounded preemption latency, like I can have a real-time algorithm along with the Java features, like something to handle tasks, whether they are scheduled in an EDF or a real-time scheduling, rate monotonic, or whatever algorithm, which adds this more complexity to that, and it also gives in more features. So it gives the more requirements which are essential for the real-time specification of Java. So any garbage utility can also be provided to have a bounded preemption latency. So if there is relationship among real-time Java threads, it can be done. So including APIs to allow communication and synchronization between the Java and non-Java tasks. So includes handling of both internal and external. Now, supposing if there is to allow communication and synchronization between Java and non-Java, this is the condition. So it has more of APIs in this condition. It also finds the relationships among real-time Java. So it incorporates some of the form of asynchronous thread condition. So the mutual exclusion should be prevented, and also blocking condition should be avoided. So the main condition is it should have a mechanism to allow code query and also to debugging feature. If there is a debugging feature is not available, again it's going to create a problem. And also there are relationship between the real time and non-real time. Now non-real time does not have a scheduling algorithm associated, whereas real time provides that. So the same is the case with the APIs. If we have more communication features, synchronization between objects like buffer features, as we discussed, buffers will catch it. The production and consumption is not same. It can take care, and also it should handle more of internal and external asynchronous events, because when it handles more of that, there will be an associated clock, and we will have to take care. As I already told you, we are going to have a virtual clock. So the reason for having a virtual clock is we need to synchronize, like one is the timings will be different for each and every process. Secondly, there's a drift associated. So for these 2 points we require a virtual clock, so there will be an associated clock also. So basically some form of asynchronous thread elimination is required. So it should define relationships that exist between the real time. The next type of language which we will be studying is about OCaml2. OCaml2 is basically a communication language. It is, and one drawback is, sorry to say that, but that's the feature of the language, it is a sequential process language. Like it takes more time in processing and a formalism, because it depends on results, and if the processor or if the thing is very complex, this language is basically not going to work. So if there are fundamental types of assignment, input, output and wait. So based on this sequential and parallel execution, it can be sent to process with an input from a channel. So the OCaml2 should support concurrency on transmitters and has some practical implementation in this thing. So in UK based condition. So the OCaml, as I told you, it has formalism. It defines formal specification in that it has a modeling, and it's basically a functional type of language. So only the basic processes would be only for 4 fundamental assignment. Other features are not available: assignment, input, output and wait. So these are experimental language. Actually we have done it only for a specific application, whether to be sequential or parallel, but parallel I don't think it will take, because it's a sequential process. So the language is basically a very restricted way. Then other type of special time languages would be Perl. Perl is one thing which it's mainly designed for the automated real-time language process and experiment thing. It is again an experimental language. All these experimental languages have a very small subset. They don't work for a very long time. Like actually you cannot try it out on all type of real-time applications. Being more specific for a particular application, a person would have designed this language. I won't say it is suitable for others, because some features may not be. Maybe the applications under this flavor and this type, language would be. Now Perl would have a set of applications which is okay. A similar requirement set if we have for some other application, we can go in for Perl. So there's no question. I can't very firmly, we cannot say Cardinal's metrics should be rigorously followed, because basically the language was not designed for that. Like an embedded is an ocean which has large number of applications, and we are dealing with a smaller subset. So for that we have met our requirement. Similarly, Euclid is again, it is suitable only for schedulability analysis. So real-time Euclid will be having a scheduling algorithm, and only for the schedulability analysis and only things we have done. So we cannot experiment other features of an embedded to garbage collecting and error handling or exception handling. All these things is not available. So basically it analyzes a scheduling type. So if I am using a cheddar source or a scheduling algorithm, I can use Euclid to analyze how effective my algorithm is going to be. Other than that, I will not be. And again, the all scheduling algorithm, it could have been designed only for a small subset of scheduling algorithms. Like I might have to, this is some area where R&D and more people could work. Like we can design languages keeping the Cardinal's metrics and scope resolution in mind, and we can for specific applications. But again, we will not be doing it in a large scale, because it's basically experimentally designed only to identify some pros and cons in that particular area. So again, it's copyrighted to an individual. He need not do it. Cardinal's metrics need not be enforced and strictly followed as far as these languages are concerned. So the next type is called as real-time C. So it has a macro extension package. It is typically used for timing and control constructs that are not found in standard C. So generally these macro extensions typically provide timing and control constructs. So it can be done. The real-time C++, a generic name from one of the several object class libraries, is used for C++. So again, the real-time algorithm part is taken care in C++. I won't say that C++ has essential features, but we need not be stringently followed. Like if you have in real-time C, as I told you here in this condition, now Euclid itself is only an experimental language for this thing, but the real-time part would take care of some more schedulability algorithms. It will also explain like how far we are achieving it through some language restriction. But again, how far that scheduling algorithm should support is a question. Like Euclid could have worked only for a particular set of applications, and the real-time algorithms for that applications could have been used. Like for example, if I have designed something for a small flight control application, Euclid will work, and Euclid will work only on that subset of real-time algorithms. It need not work like different scheduling like RM, EDF may not have constraints to do that. We'll have to devise some other language for that. So again, real-time C has the same feature. We have some macro extensions and other things to provide timing control. So the library augment condition could provide more increasing timing control where it has more libraries to C and C++, and these are basically user defined, like something like languages and packages. In packages we develop more things. Now in your C language we know that stdio.h, C++, IOST, math.h, these are prototypes or header files, and all this basic, now conio.h, all these things have functions for that. So similarly, all these functions we formulate a set, and for that working set we are designing the language. So other languages include Mac, Eiffel, Maruti, Rts. These are these conditions which are used for specific application, but they are R&D, used specifically for research only. We experiment on each type of application and we will design more things. We are trying to, ultimately the focus and objective of this is, we are trying to boil down a particular problem. We are trying to narrow down our perspective to that problem and analyze the pros and cons. So in that case, we will not make it more user friendly, or we may not be user friendliness, yes, to some extent, but we will not be working for a larger set. The set will be restricted. So when we are doing research, we will try to boil down on those problems. So that is exactly what is. Then the next thing is knowing our compiler knowledge and the rules and thumb rules. Generally, compiler we need to know in different aspects, like how far it should be optimal regarding the execution time, and also the memory requirements. So the easiest and most reliable way to learn about this compiler is to run a series of language constructs. So if we have a case statement, normally if there is an if then, while loop and do while, this condition should be there. So generally these features are available in C also. We have a switch case, we have while loop, for loop, and normally in a hardware when we talk about, we go in for something called as loop unrolling. In architecture we would have seen, so we unroll the loop depend, this is the hardware way of doing it. In a software type we use some other methods like calling for loop or if condition and case condition, the comparison of the variable types, then using inline codes, using macros are preprocessed directives, but again I told you the data types are not stringent and that creates more problem. So the coding standards is, it is stylistic convention, so it complies with the faster portability, it may have more reliability, increased reliability. So it's a set of stylistic conventions, and in many cases readability and maintainability will create a problem. So in that case we should foster the portability. Then another cases may also be used to foster improved performance by encouraging or mandating the language constructs. So it should generate more code, and the coding standards, for example, should have extreme programming. So one part would be standard or boilerplate header format. So the standard or boilerplate format means the coding should have definite standards. As I told you, we have benchmarks. When we talk about benchmarks, yes, why we are telling it's a benchmark, because we need some standard set of programs to compare. Now when we are doing a comparison, we cannot directly say that entire thing it should be done in one way. It can be, there can be additional methods, there can be more benchmark features, there can be more things. So we have to take the aspects of a large number of programs and then formulate a set, a working set to decide. So that is what is called as a standard. We define a standard, or this is otherwise called as a boilerplate header format, where we take a multiple set. Now in C we have some stdio, print operations, math.h, all these things are frequent. Now similarly we have the frequency, how frequent we are using that operation, the length of the statement, style of comments, commenting style, class names, like some things we cannot give the class names directly which are library classes directly, keywords, methods and procedures, variable names, etc. So the formatting, the basic programming source code style, indentation, all these things have to be taken care. Similarly, the size limitations on code units, either it can be maximum, minimum number, the choice of language about the rules, whether it's nested if or what. You can generally we use the Hungarian notation. The rules of this will be used with C++ and ADA. So generally we have other mangled variable names. They can be, there's the strengths of a language, but the type ultimately of embedded and the way in which the language is being formulated. So adoption of other coding standards, like it should be much to a case of starting the confirming that how far we are going to do. So when we talk about this coding standards, actually it is basically about the styling. It again differs. I won't say a coding standard should be unique. It can differ, because supposing we need to add some more features, the standard can be changed, but it should not be in a condition where the preliminary features are being eliminated. Now portability is something which has to be taken care. Now generally we have the idea of cross compilers. Why we work with cross compilers is it should be in a position to adjust. We may not be, it should be platform independent. So supposing we are trying it out on some other thing, that should be in a position to accept another processor core should be able to accept that working. It should not say that this thing. So it is ultimately what we formulate, but the basic features, like supposing if we talk about the reliability aspect, yes, the reliability aspect is one which has to be taken care of, how far we are doing it, and readability and maintainability. So it should have more constructs, and it should be more, for example, extreme programming. So encouraging on mandating on the type of language. These are called agile methodologies. So another type is normally, as I told you, the Hungarian method. Hungarian method notation is used. It has a naming variable. Why we use that is universally accepted. This C++, Ada, Java, and even C uses this notation. Similarly, formatting and indenting, we can do this in accordingly, but there should be a unique style and blend by which we adopt it to that. If that is adopted, in that case it can be worked out. So how far we can use the language, how far we are going to see that. Then of course the looping style, use case statements, like if we are using case and nested if again, if we are having more if conditions in that thing, it will again create a problem. So again, if there's a repeated call, memory will be eaten up to that extent. So we have to prevent it to some way. We have to restrict the operation also. At the same time, we need to achieve what portability is required. So the type information, what type of compiler, and how we are going to mangle the variable names. So all these things are essential features. So there are some bad coding standards also. It's sometimes we'll say that a bad coding standard is better than none, or rather than giving an attempt or doing anything. If there is no attempt being made, again that's going to be useless. If we are not having a coding standard, it's going to be more devastating, and we will not be able to try it out also. So generally it will lead to more things. Imagine if you don't have a coding standard, if we are going to totally be aloof of it, and then that is going to result in more problem. So rather than that, we have to draw the final line at some point. We cannot always see improvements. At some point we have to agree on, yes, this is a coding standard. So we can iterate, we can debate on it, how far we can improve a coding standard, but ultimately, as it says, without a bad coding standard is better than having none at all. If you are not going to have a coding standard and just like that introduce more features, it's going to result in more problem. So the choice of language is important. The criteria by which we choose the metrics are important, and some features include this garbage collection, exception collection, coding standards. But these are not all the features which are required. We need to take into account, as I told you, for an embedded system, it will be having depending on the requirement. Now our real-time languages and other features, real-time languages takes in more features which is required. This thing, and again the applications also are, it's partly application dependent. So if the application is a hard real-time system, it may require some features, and partly that rests on the user side also. The programmer has to give his effort, and in the absentia, the programmer is lightly loaded and the team is lightly loaded. Testing is not rigorous, but at the same time, all these factors need to be, it's a combined effort which is required, and unless it is being put into that extent, we will be able to achieve our requirement. So how far we work on a language and how far we achieve our requirement is again based on we need to strike a balance between all these factors, and we need to work on the problem to have a better way. Thank you for this session.